So, I'm Nadège de Chambrier. I'm based in Switzerland, in Zurich. I'm originally an environmental engineer specialized in wastewater treatment. And so Jenna presented quite well the fact that we have different technologies. Ours produce liquid fertilizer, and it's based on stored urine, which doesn't have to be pre-stabilized, contrary to what Jenna presented before. So one advantage we have with our system is that we can treat any type of urine. What we do is to treat it with bacteria. So we have a biological treatment system. And the urine is then concentrated into a fertilizer, but it's still liquid. And during the process, we remove also all unwanted pollutants, so micropollutants that were mentioned before. Our process is completely automated, and there is a patent on parts of it. And it is usually installed within a building directly, so that we collect all the urine in the building. So what we recover, I'm not going to go into the details because Jenna explained it quite well, but what we recover basically is the main macronutrients that are in urine, but also micronutrients that are very useful for plants and for bacteria in the soil as well. What we remove is the smell of the urine, pharmaceuticals, and pathogens. And the only thing we use during this process is basically the urine itself, electricity, air, and then bacteria that we put in it once at the beginning, and then they reproduce themselves. The two products are fertilizer, which we call Aurin, and distilled water. So I'm just going to explain quickly the different steps of our system and how it works. We have a collection system. So basically, Jenna presented this safe toilet before. We work with this toilet as well. We can work with dry toilets or also urinals. So as long as there is a urine separation, we can work with it. Usually we work now mainly with the safe toilet because it's the most accepted on the market. So in the basement of the building, there is a collection, a storage for the urine that is, or yellow water, which is collected. And this yellow water is then pumped into a biological reactor, which is aerated and which has an automation. So we have different parameters that we observe, like pH, for example, and the bacteria transform the ammonia present in the urine to nitrate. So at the end of this process, we have removed the smell of the urine because the ammonia has been reduced and the pH is lowered. So similarly to what Jenna presented in her stabilization process, where, for example, the pH has to be lowered, we do the same, but after storage and biologically. After this biological reactor, we have an activated carbon filter. This is quite standard in wastewater treatment. So there is a lot of experience with it, showing that it can very well remove all micropollutants, so drugs, hormones, etc. And having this activated carbon filter has allowed us to for our fertilizer permit in Switzerland to use the fertilizer for all types of plants and not only decorative plants, but also edible plants. The last step is a concentration step and hygiene pasteurization. So basically the urine is passed through a distiller, which is working with high temperature, so 85, 90 degrees. And on one side, we have the concentrated product, which is the fertilizer. And on the other side, we have the distilled water. The distilled water can be reused after treatment for as would be grey water, for example. If it's not treated, it can be reused for flushing, for example, or watering plants. But it's not drinking water quality. So this is how the product looks like. For now, we sell it mainly in half-liter bottles. It's been on the market for a few years now. We have authorization in Switzerland, Liechtenstein, and Austria, and we're working on authorization in France and Germany. We've already treated quite a lot of liters of urine, produced quite a lot of fertilizer based on that. And an advantage we have is since there has been so many years of production, there is also a lot of field studies that are completely separated from us, so very much objective on the product and showing quite positive results comparing the product to other similar products on the market, which are from synthetic sources. I'm just going to go through a few projects so that it's a bit concrete what we do basically. I'm going to come later to the business model and how the company works. So the main project we have, and the first one we have, is at EAWAG in Switzerland. This is a water research institute in Switzerland. And this is where the technology was developed originally. And so this is where many things were tested on urine in general. So whether female urine was very different from male urine. So there's been research on that for more than 20 years here at EAWAG. And there was a plant installed, I think about 12 or 15 years ago on site, and it was treating about 100 liters per day. And this plant has been renovated or increased 1 year ago, and can now treat 400 to 500 liters a day. And we did that because actually before, can you see my mouse?
Yes.
So, okay, thanks. So before we were treating only the urine from one building. And what is special in this project is that we have connected 2 other buildings to the main treatment. So we have the first urinoduct, we call it. So urine pipe connecting buildings together in the world. And it's quite interesting to have this experience also long-term to see what are the advantages or disadvantages of such a system. But it allows to have a kind of semi-centralized system already. In these buildings, the other thing that's quite interesting is that we have a mix of different urinals, different flushing toilets. So in the very new building, this flux building here at the bottom, it's only Lauf and Safe toilets, which have been installed for now a year. And in the older building, which is here, this one in green, which is the Forum Griesbach, it's still Rödiger toilets, which have this kind of separation wall and different types of dry urinals. Another project I want to talk about is the one that we do now with zirkulierBAR. It's in northern of Berlin in Germany, where we have just finished installing a treatment plant, which is completely decentralized. So it's very different to what we've done until now. It's a container-based installation, and we work together with Finizio on this. Finizio does the collection of the urine. They have dry toilets all around the region, and they also do the composting of the fecal of the feces. And we take care of the treated. We do the treatment of the urine on site. So on this decentralized site. So that was the only good picture I had of it actually. So we were building this the last few weeks. So you can see the container, everything is recycled. So even the container is a second-hand container, and we tried to, in this project, to have really as many, to have it also fully sustainable. So everything is really recycled. And this system is now being commissioned. So it takes, because of the bacteria in the system, it takes a few months to really come to a full treatment capacity, but the goal is to treat 400 to 500 liters a day as well. One special element also about this project is that the urine we treat is from different sources. So it's very much, it's very different from one batch to the other. So here, as you see, we have on this picture 5, but in general, it will be 6 IBC containers. And some of them have urine that has passed through feces. Some of them have urine that has just been from a dry urinal. And so in the end, it's urine that can be very rich, also in other matter, in organic matter. But we know that for our process, it's not a problem, and it's a good advantage that we have. But it will be interesting to see with those different sources if the process can be as stable as it is when it receives always the same kind of urine in a building, for example, where it's always the same people using the toilets, etc. So where we can expect to have people eating relatively in the same way or drinking the same amount of water all year long. Another project that we are starting beginning of August is at the European Space Agency headquarters in Paris. This is for us a quite important project because it will be flagship. Many people talk about it and many people are waiting for it. The advantage of it is that this is really, it's going to be kind of a showroom. There is a lot of demand for those systems in France, and many people are waiting for us to install a system closer to them because they don't want to just see the system that we have in a research institute, but they want to see it in a real building where we're not around. This is a quite small plant. It's treating 200 liters per day. And per year, this corresponds to a production of about 5 cubic of fertilizer. Our goal is really to find a way to use the fertilizer as close as possible to where it's been produced. So for example, in this case, there is the UNESCO has a very big field, also a lot of green field, and they have installed also gardens on their roofs. So we're hoping to be able to use part of our fertilizers there. The city of Paris is also quite interesting to use it in their gardens. So it's really the goal for us is not so much to export it on fields, but rather to try and keep it as close as possible. I think one last project I wanted to present is this eco village in Hanover. It's quite interesting because in this case, it's really a neighborhood. So it's quite different from what we've done until now, usually in one building or a few buildings, but in this case, it will be more. It's quite a large treatment process, so with 600 liters per day. And we are working also together with different partners on this project. Also with Sanitation 360, it's the same project founded by the European Union. And this one will be delivered during the year of 2024. So now it's still in planning for now. Quickly about the business model, so you can understand how it works, basically. Our idea is to have systems that are installed in the buildings. So we plan, build, and maintain the systems for the treatment of urine inside of the building, and someone pays for those. So usually it's the building owners who will invest in the treatment plant, because for diverse reasons, there are really all kinds of reasons for an owner to want this. Mainly it's because they want to do something for the environment. And what we do also at the end is taking care of the fertilizers, so doing really also all the logistics linked to this. We have decided to do it this way because we see that no building owner wants to take care of fertilizer themselves. Often they already have solar panels, so they often say we're already electricity sellers, we don't want to become fertilizer sellers. And so we saw that it's better to have a global system, and they don't have to take care of anything. So we basically do everything. And what we are trying to prove now, and it's a 2-year pilot project that we are currently doing, is to show that we can make money with the fertilizer. It's not a lot of money, but it should be sufficient for the systems to be cost neutral, or to have at least a return on investment for 10 or 15 years approximately, depending on the size of the systems, of course. And that's it. So I'm happy for questions if you have any.